So guys, welcome back to Practical Machine Learning series. This is lecture 4 and today we will be looking at intermediate data selection using pandas. So let's look at today's agenda. Today we will be looking at intermediate data selection with pandas. Particularly we will be looking at intermediate analysis using the complex conditions, how you can build multiple complex conditions, chain them and try to do some filtering or data selection using that. Also we will be looking at how to load libraries and modules, and I will be showing you some of the interesting ways to create the data frame, kind of a recap there. One thing to note is that the revision sections are completely optional and part of the homework, so I will not be covering them. You can always revisit them and it's very good to know those particular tips and tricks which I have covered in our revision sections. If you want, I will create a separate video on that, but let me know that in comments. Now let's start today's session. So first thing first, why do we need a new notebook? So here we are creating a new data frame with dummy values. Earlier was not fit for analysis, and that's why we need a new notebook to start everything very clean and nice. And now let's look at how to load our libraries and modules. It's very basic stuff. We will import pandas as pd, cbond as sns, matplotlib.pyplot as plt, and numpy as np. These are the basic libraries that we need for this particular notebook. Okay, now let's create new data frame, and here I will be showing you some interesting stuff. Okay, now let's say you want to create a data frame. You are already familiar with pd.dataframe method, which will create a data frame from a list of objects or series. But now let's say you want to add some random values. How you will add that? It's very simple. You have to use numpy random.rand module and pass in the number of rows and number of columns. So this 10 is number of rows that we want and 5 is number of columns. Now next you can pass in the index. Index basically means the row index that we have seen our last lecture, and here rather than passing 0 1 2 3 4 5, I am passing a b c d e f g h I f, and after that I am converting it back to the list. Then I am specifying what are columns. One thing to note here is that guys, this particular index will be same as the number of rows, and this column values will be same as the number of columns. So if you have wrote here 5, then you need to pass in till e, else it will throw an error. So this is our base data frame and this is what we have did. But this is very hard to understand, because let's say you have 10,000 of rows you want, then whether you will be writing this index thing and then creating the column values? No, you will not be doing that, right? You need some way to make things very simpler, and that's where this range function comes in. Everything remains same here in this particular code, except that we are using range here. What range does is it creates a list of values from 0 to whatever number is specified, or whatever start index to end index is specified, and that will be index, and then our column names. Since we have only kept our column name as 5, that's why I'm using ABCDE only. One thing which is very important is that this range value should always be less than the number of rows that you have specified, because in case it is greater than that, it will throw an error. You can see that for printing head, I am getting this value ABCDE, which is our column name, which is kind of column index there, and 0 1 2 3 4, which is in log terms, it is 0 1 2 3 4. Now what is the benefit of this particular method? It is very simple, that you can specify start and end index for your range function, which means that you can get a specific subset of values as observations. Let me show you. Here again we have created a data frame. Again I am taking 100 rows and 5 columns here, and index value is from range 10 to 110. So what it will be doing is it will be creating a list of values from 10 to 110, and then it will be setting it as index, and then column values will be A B C D E, because we are using again 5 columns here, so that's not a worry of thing. Now one thing to note here guys is that this particular difference, that the start index and end index should always be equal to the number of rows. If it is not there, you will get an error. Let me show you. First of all, normal one. You can see that it clearly creates our thing, and our index starts from 10 to 109. Now one question for you guys is that in terms of log, it will be 10, 11, 12, 13, 14. But in terms of ilog, what will this particular row indices represent, and what will be the value of those two indices? Okay, this is kind of homework. You can always answer them in comments. Now here, if I change this value to say 111 only, now you can see that difference will not be equal to 100, and see what this throws. It throws a value error that shape of past value is 100, 5, indices imply 101, 5. Now if you have 100 rows, it can't create an index, right? So that thing you need to take care, and it is a common issue that people face while using this particular method. Now again, if you have this issue, how you can fix it? Either you can increase the number of rows to be a difference of this particular thing, or you can change these particular range values, start index and end index, such that their difference match the number of rows. Okay, so that's for our creating new data frame. Now let's look at intermediate analysis, that is building complex conditions. So in our intermediate analysis using complex conditions, there are three methods. First one being the lambda function, second one using selector mask, and third is the using operators. So let's look at how to use our lambda function for our selection. Okay. So a brief intro about lambda function. Lambda function is kind of an anonymous function. That means you don't need to define the def keyword or the body of the function. You can do it in one line, and it can be used with a variable, and variable can be used as a function there. I will show you that thing. Why we use this? Because we pass this particular lambda function as our log selector. So using lambda function, we create expressions or the conditions, and then we pass it as the function in df.log, right? Now basic lambda function syntax is that you have a lambda keyword, then you have an iterator or variable, that means this variable or iterator, whatever you are giving that thing, and then the expression. Make sure that this expression uses the same iterator or variable there, because what will happen is the Python will look into the lambda function definition and it will check if that iterator is present or variable is present or not. If it is present, then it will perform the operation based on that. And let me show you this particular syntax using an example. Here, as you can see, lambda dfc is greater than 0. So what it means is lambda is our keyword here. Then we have our df is kind of a variable, but again it is a data frame in itself. And then data frame, we are accessing the third column, which is our c, and we are saying that our condition is that all the values in column c should be greater than 0.3. That's kind of expression which we call as conditional expressions. Now these expressions can be of many types, like conditional operations are there, arithmetic operations like plus, minus, multiply, divide, percentage and everything like that. Boolean operations are there which returns true or false values, and simple operations like selecting multiple columns and those things are there. Now let me give you an idea of how you can do that. Again, don't get misguided with the selector here. You can always rename it as conditions. Okay, here just for understanding purpose I'm using selector. So selector 1, and as you can see, this is a variable, but here what we have passed? We have passed our lambda function, right? And again, what this is doing, it is taking our data frame and it is again checking whether the column c values is greater than 0.3 or not. And this particular syntax makes this selector 1 actually as a function, and let me show you that. And you can see that it says that function underscore main dot lambda df. That means that this is a lambda function in itself, and we can use this in our log selector. By default, you know that log actually returns the row indices of this particular data frame, right? So for this condition, whatever row indices satisfy that, it will return. Okay, now you can see that we have this value. Let me check. C is greater than 0.3. Let's see, 0.7, 0.3, 0.7595. Yes, we are good to go because we have actually selected that. Now this is not very obvious, guys, means why we are using lambda. We can directly do the expression, but let's change a case a little bit. Let's increase the complexity and try to chain multiple conditions. So here we are chaining multiple conditions, like we have our column B which has value greater than 0.3 and column C which has value greater than 0.3, and again we have a column E which has value less than 0.6, and we have tied them all with multiple AND functions. Now here again we are using lambda function, but rather than using multiple df, we are only defining one single variable df, that is data frame, and data frame is again being used everywhere. So this is the kind of benefit that you have. Say you have 10,000 of rows and you want to access it like this. Obviously you have to write the syntax, but you can use this particular df variable or data frame once, define it, and then you can use it again. Okay, one thing to note here is that you have to separate each of your expression using the small brackets, so that Python or any coding language knows that yes, this expression need to be evaluated first, then this, and then this. All these will return masked values, that is true or false, and then it will check the intersection of these three values. Where this all three will satisfy, that's only it will return. Let me show you the selector, and again our selector is a function because we have used our lambda variable there. Now same thing, again we are using our selector and passing it to our log function. Again it will filter out the same thing. and but now you can see that it will only filter out those rows which satisfy this particular condition. B has value greater than 0.3 for all, yes. For C we have greater than 0.3, yes. For all, yes, it is there. And for E it is less than 0.6. So you can see it is there. Now this is cumbersome because here we have to write multiple expressions for that and separate them out. Is there a way to chain or club things? Yes, you can do that, and you can use it using all methods. So here again we are using the lambda function, but here we are saying that since B and C is always greater than 0.3, same value, so we have clubbed them together, and the syntax I have shown earlier in my last video, you can refer to that. Here we are just taking B and C and passing it as a list inside a list, okay, greater than 0.3, and then I am using dot all x is equal to 1. That means the rows of all the values where this particular condition is true, okay. And then using the and, I am clubbing like df of e less than 0.6. Again, it will give you the similar values, but this is very useful in case you have, say, very large number of rows which we want to filter out on a same condition. Let me run it using the loc. I have passed this selector and it will return me the row indices, and you can see that it is the same value deh, and here also deh, and same values are there, okay. So this is very important to understand, and this is how you can use lambda function. I have just shown you a small glimpse of thing. You can always practice it. Now moving on to our selector mask. You have already used this particular thing, but you don't know about this, why we call it mask. So let me be clear about that. So selectors are simple expression that returns true or false values. Often conditional operators are used in them. So conditional operators like and, greater than, they are used a lot for this particular selector. But if you see here, we have a selection condition variable, and again you remember this is our code from the lambda section, right? Chaining multiple columns and conditions, okay? So if I run this now, you can see that we have a series of values which has false and true, and we call it mask. The reason for calling it a mask is because if it is true, that means that the value will obey this particular condition that B and C column has value greater than 0.3 and E column has value 0.6. Else false, that means it is not obeying. So it's kind of representing the entire observations there in a different way. That's why we call it a mask, okay. You can just pass in this, and again we are getting DEH, okay. So this was basic on selectors. Now let's move on to our operators. Now for the operators, you need to focus on two main operators. First one being the OR operator and second one being the NOT operator, represented by pipe and tiddle. The pipe is located between your backspace and enter key, while tiddle is present just below your escape key. So make sure that you check it out. Now let's say you want to use condition using OR and NOT. How you can do that? Let me show you an example. So let's say we want that our column A has value greater than 0.2 and column B has values greater than 0.2. One simple way is to write df of A greater than 0.5 and df of B less than 0.2. But in some interview, they will say that you need to use this particular two operators only. Then how you can do it? Let me show it to you. So just use the NOT operator on df of B less than 0.2. That means all the values for the B column where value is less than 0.2, and NOT means that it will be greater than that. And then using the OR operator, you can find the condition where A is greater than 0.5 or B is greater than 0.2. Once we have done that, you can find that if I use the df.condition for selection directly rather than using .lock, you can see that A, D, E, F, all these are index values, A, B, C, D, E, F also column name or index value. And let's verify that whether we have this particular condition met or not. A greater than 0.5, there are some of them, but since it is an OR, that means if even B is satisfied, that means A will not be satisfied, even though it will be returned, okay. So this was for using operators. So this is the intermediate analysis. Obviously there are more which we will cover later on as we come along them, but for now make sure that you do this, and let's move on to your homework. Homework is very simple. You just need to practice whatever is present in the notebook, including the revision section. So if you see, I have created revision on exploration of data frame using pandas and revision on data selection using pandas. So all the code is available. You just need to run it and check it out. Also, there are some tips and tricks which I have included in this particular section, which you can explore. And if you have any issues, please let me know in the comments. For resources, you can just refer to the GitHub link where I have been putting all my notebooks. And then we have pandas indexing and selecting documentation. So indexing and selecting, this is very important. Loc and iloc has been very clearly explained here. So I highly recommend that you please check it out. Also, there are many things that has been changed. So you can directly get to know this using this warning. Okay. Now, finally, last but not the least, we have our series playlist. So I have uploaded 3 videos. You can check it out later on. So I hope that you understood few things here and there, and it will help you a lot later on. So guys, that's it for this particular video. I hope that you will do your homework and do share your thoughts in comments. See ya in the next video. Till then, bye bye.